So the last video in this section is interesting because of what it allows us to predict and say about polynomials, the way that their graphs are going to behave. And it's called end behavior. And by end behavior, I mean what happens on the extremities as we go away from the origin, far to the left or far to the right. How is the graph going to behave? And this is based on the degree of the polynomial. So when I say degree, I'm talking about the magnitude, magnitude, as in the size of the exponents. How big are the exponents? The magnitude of the exponents, how big they are. So as in x squared as opposed to x to the third, as opposed to x to the fourth, as opposed to x to the fifth. Now, I don't mean these collectively. What I mean is, what is the largest degree? So if I have x to the fourth power plus 2x cubed minus x plus 17, when I say degree, I'm only referring to the largest exponent. So we can have multiple exponents in there, x to the fourth, x cubed, and this would be x to the power of 1, understood x to the power of 1, but I'm only interested in the highest degree of a particular polynomial. What is the largest one it is? So when we look at the degree of a polynomial, we are specifically referring to what is the largest exponent it has in that polynomial. Now, it is traditional to write polynomials in order, descending order, starting at the largest and going down. So generally, it'll be listed here at the front, but you need to make sure, glance over, make sure that it actually is in order. Sometimes they mess with you. But here's what we know. When I have an even degree, as in the largest exponent on a particular polynomial is x squared, or x to the fourth, or x to the sixth, and so on, ... What that tells me about the behavior of that polynomial at the end, at the extremities, is that it's going to behave more or less like a parabola. It's going to behave like a parabola. And here's what I mean by that, like a parabola. So you know that a parabola is this fancy U-shaped thing here. And as you can imagine, when you start getting into x to the fourth, x to the sixth, and so on, stuff gets more sophisticated, and it does. But if I have an even degree, I know that no matter what craziness happens in the middle, both ends are going to end up pointing the same direction. So in the same way a parabola starts up and goes down, then comes back up, an even degree will do the same thing. Now, when you look at transformations, it is absolutely the same as parabolas. And what I mean by that is this. If we think about a reflection over the x-axis, as in a concave down parabola, that is also true. If I have a leading coefficient that is negative and has an even degree, there's going to be some amount of interesting stuff that happens in the middle. However, if it starts down, it will end down. If it starts up, like this one does, it will end up. Even degree polynomials will always end in the same direction it began. So if it started up, it'll end up. If it started down, it will end down. And that is true for all even degree polynomials. So it begs the question, what do odd degree polynomials do? Odd degree polynomials, if you want to get a feel for that, you would look at something like a basic cubic function. So the cubic function, f of x equals x cubed. If I make a plotting of points real quick, it'll look something like this. It starts down from left to right, flattens out a little bit, and then skyrockets up. So it starts down and it ends up. And that's going to be true for all odd degree functions. Now, once again, the more sophistication you add, the more pieces you add, the more interesting stuff will happen in the middle. However, what will be true is that they will end in opposite directions. So if I start up and I wave around, then I'll end down because it ends in the opposite way that it started. Similarly, if I start down, I can have some interesting stuff in the middle, but it will have to end up because odd degree polynomials always end in opposite directions. And these are truths. You can take that to the bank. It will always be that way. Even degree polynomials will always end in the same direction, and odd degree polynomials will always end in the opposite direction from which they started.